Hey, it's Dr. J. 4.6 today, adding and subtracting mixed numbers. So we've already done a lot with fractions here. We're getting close to the end of the chapter, so I'm not really going to give much of an introduction. Just going to jump right in and do some problems. We'll start off with the easy ones where you have common denominators already. Something like this. So if the denominators are already common, it's essentially like I'm giving you the answer, really. You don't really have to do a lot of work for these. So for this example, let me just sort of demonstrate the technique. You can do it horizontally if you're good with mental math. So if you have good mental math skills, you can just read the question, write down the answer. 5 plus 3 is 8. And then 2/7 plus 3/7. Oh, I screwed up. That's 5/7. So the problem with the mental math thing is just, as you just saw, you can easily make a mistake and then not even realize you did it unless you double check yourself. So that would be sort of the mental way. It's not that reliable, right? You want to have more of a systematic approach of doing it. So the safe way would be to stack them. So this is how I'll, in general, do these problems, especially when they get more complicated. I mean, for an easy one like this, I should get the same result. But so you want the whole part and the fractional part to sort of be separate. So you're going to add the whole parts. You're going to get 8. 5 plus 3 is 8. And then if the fractions already have the same denominator, so the denominators are already the same, they're already common, you simply add the numerators. 2 plus 3 is 5, and you're going to get the same result that I got doing it using mental math. Okay. So as you're going through the problems, I encourage you to, I'm sure there's a few problems on there that you can just read the question and type in the answer, and you don't really have to, do a whole lot of work. But I mean, I wouldn't expect too many of those. You're probably going to have some problems that involve work. So let's try another one. Another easy one where the denominators are already the same. Something like this. Okay. So let's just go right to the stacking. I recommend, if you're doing this on your notebook, don't even write this down, right? So this is what you see on the screen, but you should immediately rewrite it. It doesn't matter who goes on top. Some people insist that you put the larger one on top and the smaller one on bottom. That's not really a law. There's no law like that. You can put them in any order you like. When we get to subtraction, I might have to be more careful about the order. But you remember, addition is commutative. You can change the order, and you're still going to get the same result. So watch what happens this time. You're going to get 5 plus 4 is 9, all right? And then when you add 7 ninths and 5 ninths, you're going to get 12 ninths. If this is improper, then you need to carry. We call this carrying. Yeah, the whole part. It's usually 1, but I mean, sometimes it's bigger than 1. And you remember when you're elementary school, carrying the 1 or something, but you could be carrying a 2 or carrying. So I'll just say the whole part and then add to the 9 here. All right, so you want to try this mentally, or you can write it out. Let's try it mentally. 9 goes into 12 one time, with a remainder of 3. Yeah, so that will be the whole part. So it's going to be 9 plus 1. Yeah, so you're going to add it to the whole part here, 9 plus 1. And then now 12 ninths is no longer 12 ninths. 12 ninths is now 3 ninths. All right. And so now you have 10. 9 plus 1 is 10. And then 3 ninths. 3 ninths is 1/3. So the answer is 10 and 1/3. Okay. Now, that's only because 3 and 9 have a common factor, so I was able to reduce it. If you cannot reduce it, I'll just put here in my note here, reduce, also known as simplifying, if possible. So I got 10 and 1/3. All right, that's it. The honeymoon's over. Okay, now the rest of these problems we're actually going to have to do a little bit more sophisticated mathematics because we're going to not expect the denominators to always be the same. That's too much of an expectation, right? Occasionally you get lucky and the denominators are already the same, but maybe not. All right, so you got 3 1/10 plus 2 1/6. Again, I would immediately rewrite 3 1/10 plus 2 1/6. So the denominators are not the same, so you need to find an LCD. Now, again, I've already gone over this several times. Sometimes you have a gift. You just, boom, you read it, and you pop in, you go, the LCD is 30. All right, you might just see it. All right, I hope that we get to that point where you just look at the numbers and you go, oh, the least common denominator is 30. All right, if you're not quite there yet, I'll explain it one more time, okay? So how to find 30? Well, you're going to write 10 is 2 times 5, and 6 is 2 times 3. Yeah, it's the same process as an LCM. Yeah, same thing, same process. All right, and then you look at what they're missing. Yeah, the 6 does not have a factor of 5, so we're going to give it a factor of 5. Now they both have a 5, they both have a 2, but you might notice this one is missing a 3. Factor of 3. And now they're all the same. Look, 3 times 10 is 30. 5 times 6 is 30. 2 times 5 times 3, that's still 30. And 2 times 3 times 5. So these are all 30, and that's the common denominator. I've checked it out now. All right, now, the reason why I like to show this work is this tells you, this side tells you what to multiply by. So this side tells you what you're going to multiply the fractions by. So it says, oh, I'm going to multiply the 10. I'm going to multiply that by 3. Yeah, numerator and denominator. Make sure you do both. All right. And then the 6, it looks like I multiplied it by 5, so we're going to multiply by 5. All right. So if you do the LCD in your head, then you just have to know what these numbers are because you did it all mentally. But if you write out all the steps, well, then you have a record. I call this a receipt. Yeah, it basically tells you what you paid for it, right? In case you forgot. All right, so now we've got 3 3/30 plus 2 5/30. And now you can add these together. 3 plus 2 is 5. 3/30 and 5/30 is 8/30. And then reduce this if possible. So 8 is 2 times 2 times 2. And 30 is 2 times 3 times 5. Now, again, we've done a lot of these before, so I'm jumping ahead. 8, that one happens a lot. 2 times 2 times 2. 30 is 6 times 5. So I wrote 2 times 3 times 5 because I want to cancel a pair of 2's. And so your final answer is 5 4/15. Yeah, 2 times 2 is 4. 3 times 5 is 15. Okay. Whole numbers. This is essentially a free answer. You don't have to show any work at all here. This is absolutely free. Yeah. You see why? If you're adding a whole number to a mixed number, then you only add the whole parts and you keep the fraction the same. So this is essentially a free answer. Yeah, 8 plus 4.5 is just 12.5. So there you go. I don't have to show any steps. I don't have to do a common denominator. I don't have to do any of that stuff. Okay. So let's move on to subtraction. Now we might as well give you another free one. Subtraction is very important, though. You have to do it in the right order. So you can't change the order, right? Addition doesn't matter. Yeah, 8 plus 4 is the same as 4 plus 8. Yeah, but that's not true with subtraction. With subtraction, suppose you have 9 5/6 minus 4. It must be done in this order. All right. So be careful with subtraction. The order matters. All right. If you accidentally put it in the wrong order, it will be wrong every single time. Now, however, this is still a free answer. You're going to subtract the 4 from the 9. Okay, and then keep the fraction the same. So the fraction part is still going to be 5/6, but the whole part is going to be 9 minus 4, which is 5. Okay. You really don't need the parentheses. I was just doing that as a grouping symbol to show you that the 9 and the 4 are combining to become 5. All right. And then keep the fraction part the same. 5/6 is still going to be 5/6. So with addition, the order can be changed, and you would still get the same result, same value. With subtraction, that's not true. If we change the order of subtraction, I'm putting the 5/6 over with the 4 this time. We'll get into negative numbers later, but for now I'm just trying to sort of break the ice here. So now the order matters. You got to be very, very careful. If you are subtracting a fraction from a whole, you cannot just subtract the whole parts anymore. You can't do that. What you need to do is rewrite it 9 minus 4 5/6 And we sometimes refer to this as borrowing. You need to borrow from the 9 in a special form. And that special form is going to have the same denominator as the other piece of the fraction. So we're going to rewrite this as 8 6/6. That's the special form of 1. In your mind, what this really means is 8 plus 6/6, which is 8 plus 1, which is still 9. Okay? So you're not actually changing the 9. You're just rewriting it in a special form. You're writing it as 8 6/6. That still means 9. Yeah? Now you don't have to do anything with the 4. Just bring it down. Minus 4 5/6. And now you can subtract the whole parts. So 8 minus 4 is 4. And 6/6 minus 5/6 is 1/6. And so that's your answer. You can't reduce 1/6, so we'll just leave it alone. All right. So that's the basic idea with subtraction. All right. If the top fraction, which is the first fraction as you read it from left to right, that one must go on top when you're subtracting. Okay, and then if necessary, you're going to need to borrow. Let's try another one. All right. So this time they're both fractions. Yeah, 5 3/8 minus 1 5/8. You must put the first fraction on top and the second fraction down below, or the second mixed number down below. Okay. Now, 3/8 and 5/8, you can't subtract. We're assuming we're not going to go into the negative numbers here. We might eventually get into the negative numbers, but for now I'm assuming you cannot take away 5 from 3. So you need to borrow 1, right, in a special form. So just look here. 1 is equal to 8/8. All right, you can just do that mentally. So we're going to borrow it from the 5. So the 5 is just going to become a 4. And then we're going to add. That's what borrowing means. You know, you're going to add 1 to this guy here. So I'm going to rewrite it one more time. 4 11/8. Yeah, you're just going to add these together. 3 plus 8 is 11, so that's 11/8. All right. Now you can subtract. 11/8 minus 5/8 is 6/8. And then 4 minus 1 is 3. Reduce or simplify if possible. Can we reduce 6/8? Yeah. Yeah, we can. 6/8 is 2 times 3, and 2 times 4 is 8. 2 times 3 is 6. Cancel a pair of 2's, you're going to get 3/4. So your answer is 3 3/4. There you have it. All right, well, you probably know what's coming next, right? Subtraction where the denominators are not the same already. Yeah, we're going to need to tackle that one next. So. Subtraction when the denominators are not the same. So this will be a little more sophisticated technique. Again, you're going to put the first mixed number on top, second one underneath. I mean, you could certainly try to go horizontally. They're on a really simple problem. You don't need to rewrite it like this, but there's not going to be very many of those. Most of them are going to require some rewriting. Okay. Now, don't do any borrowing until after you've done the LCD, because sometimes once you do the LCD, you realize you don't need to borrow, right? So it might just sort of work itself out. Let's cross that bridge when we come to it. So let's see if we can do quick mental math on the LCD. 12 and 8. Does it pop in your head right away? 24? Yeah, 24. 24 is the smallest number in which 12 and 8 both go into it. Okay. Now, I don't know. Did you see that? Some people go too big. Right? 48, it's too big. It's not the least. 72, again, it's too big. It's not the least. Right? All right. And others folks go too small. All right. I often get people will say, well, 4. Yeah. 4 goes into 12 and 4 goes into 8. But that's too small, right? Because you don't want a number that goes into these numbers. It's the other way around. You want a big number, not too big, but it's typically a larger number, typically larger than both of these, in which both of these divide into it. All right, and then if you have to do it this way, what's 12? 2 times 2 times 3. What's 8? 2 times 2 times 2. Okay, this one needs another 2 because they both want to have the same number of 2's. And now this one wants to have a 3 because they both want to have 1 3. And now you can clearly see that this is 24. All right, so then over here, I'm going to multiply this one by 2. That's the nice thing about doing the scratch work, as it sort of tells you what you need. And then the 8 needs a 3. All right. And I like to rewrite it one more time. 14 and 14 24ths minus 4 and 15 24ths. So now look here in the numerators, you're going to need to borrow. Yeah, 14 is smaller than 15. So we need to borrow. So we're going to borrow 1 from the 14. That's going to make that a 13. And then we're going to add 1 in a special form that's going to be 24 24ths. Again, I'm just doing that with mental math. All right, I'm rewriting it again. 13 and 38 24ths. Yeah, 14 plus 24 is 38. And then the bottom is 4 and 15 24ths. I'm running out of room. Normally I'd put my answer down here, but I'm going to put it over here. 13 minus 4 is 9. And then 38 minus 15 is 23. Yeah. It's probably better just to be right. In other words, just do the process correctly and get the right answer. Occasionally you might make a mistake. A quick way to check, although it's really not very quick, is to take your answer, add it to the second number, and then see if it checks out to be the first number. There are fancy names for this. This is called the subtrahend and the minuend. I'm not testing you on those words, so I'm not even going to write that down. But I just call them the first and the second term, or the first and the second mixed number, however you like to call it. Thing one, thing two, if you like that. All right. Let's keep going. Just pausing for dramatic effect there. Okay. $13 7/10 minus 2 3/4. Okay. I can't tell if that's my glasses or not, but that's close enough, yeah. It seems a little fuzzy, but that's okay. Let me rewrite it. Maybe things will work out when I'm rewriting it. So 13 7/10 minus 2 3/4. Right. When you get really good at these, look how you can do it. The LCD is 20. So I'm going to multiply this one by 2, and I'm going to multiply this one by 5, and now you have an LCD of 20. It is getting blurry. I know that's not just me. All right, well, I don't know. Don't stop me now. All right. So this is going to be 13. Here, let's go this way. 13 14/20, and then 2 15/20. Oh, we have to borrow again. That is really bad. I don't know what's going on with my camera. All right, well, hopefully you all can see what's going on here. I don't know what's going on. I can't stop now. All right, so I got to borrow again. Yeah? So we're going to borrow 1. Oh, there we go. This is going to become 12, and then we're going to add 20/20. Yeah, that's the 1. We're borrowing 1. So now I've got 12 34/20 minus 2 15/20. So I'm going to get 10 19/20, and that's my answer. It's hard to tell whether you're going to have to borrow, right? So you don't want to borrow until you get to the step that has the LCD. Once you have the LCD, then you can look if the numerator of the top is smaller than the numerator of the bottom, then you need to borrow. Maybe I'll do one more. Might as well stop on number 10 for these problems. I don't think we're getting into the negatives today, are we? I said maybe we might get into the negatives, but it doesn't look like we're going to have any negatives today. So 5 and 11/12 minus 2 and 1/4. Again, you got to put the first term on top, the second term on the bottom. This time, since 4 goes into 12 exactly 3 times, the LCD is automatically 12. Hopefully that's catching on. I kind of made that point at the beginning of chapter 4, but it sometimes takes several, examples of that. You go, oh, okay, sometimes you don't have to change both numbers, right? A real common mistake is simply to multiply these 12 times 4 and get a big number like 48, and that's just overdoing it. You want to be cheap, right? Think of it like it's costing you something. So you want to sort of pay the bill with the minimum amount so that you can save it for later. Okay. I mean, that's the philosophy behind it. Of course, you certainly are allowed to do whatever you want, but I recommend that you do it this way. So if you notice that one of the denominators goes into the other denominator, then the LCD is automatically the bigger denominator. And you might notice this time, no borrowing required. And no borrowing. So 5 minus 2 is 3. 11 minus 3 is 8/12, but you do have to reduce if possible. You always have to reduce if possible. So that's going to be 3 and 2/3. Now I did that mentally. Let me show you how I got 2/3. 8 is 2 times 2 times 2. 12 is 2 times 2 times 3. I did all that in my head while you guys were watching, and I'm canceling the 2's, and that's how you get the fraction part to be 2/3. Okay, so good news is we're done with the basic content. The better news, or for some folks the bad news, is that we have to do some geometry. We're going to introduce variables, and I got to do a couple word problems. Just little one-line word problems, not the big, paragraph story problems. Not quite yet. We'll get to those later. All right, so these first 10 examples are kind of just getting the basics moving. Let's do some geometry. Now, at this point in the semester, I know I get a lot of students that have anxiety about geometry. At this point in the semester, you really only need to know a couple things. We talked about area, we talked about perimeter, and typically that's about it right now. It's going to get better as we move forward, but for now, today we're just going to talk about perimeter. You can kind of tell by the theme of the lecture. Today's lecture is on adding and subtracting. Yeah. So in particular, perimeter is adding. Yeah. Peri. Peri means outside. Yeah, like peripheral or perimeter. The outside, the fence. And you're just going to add up all the sides. This is called a trapezoid. Yeah. A trapezoid has 2 parallel sides and then 2 non-parallel sides. We call that a trapezoid. I typically label it A, B, C, and D. That's my trapezoid. All right, so I want you to find the perimeter. If A is 3, B is 2.5, C is 5 3/4. And D is 2. So B is just a little bit longer than D. I don't know if you could tell that by the picture, but it's kind of more like this. So these are not the same length, even though they often visually might look similar, they're not the same. Okay. So essentially what we're going to do is we're just going to add up all the sides. A plus B plus C plus D. That's the perimeter. At some point, we're going to talk more about area, and the formula is a little more complicated for area. But for perimeter, it's pretty straightforward. You just go around and add up all the sides. All right, so I got A is 3, B is 2.5, C is 5 3/4, and D is 2. Now here's what you can do to make your life a little bit easier. You can group your whole numbers together and the mixed numbers together. That makes it a little bit easier because the whole numbers, you just do them mentally, right? You're going to get 3 plus 2 is 5. The mixed numbers now, you're going to do it the way we did it in the first example. First couple examples. All right, so basically just like we already did. Okay, now if you're really good at mental math, you can probably figure out what this is. This is going to be 9 1/4. Yeah, you good with mental math? Just think about money. Yeah, this is like $2.50, and this is like $5.75. And if you have $2.50 and $5.75, by the way, that's another reason why they're called quarters. Yeah, 3/4, 75 cents. You know that you're going to have $9.25. So, I mean, if you deal with money, money is always a real simple way to resolve fractions in your mind because you deal with it all the time. I mean, unless you're just swiping your card and not really thinking about what's actually going on the other side, right? And I remember back in the day when you actually used paper money and coins all the time, it was probably a lot easier to keep track of that stuff. Nowadays, we just swipe, 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 and check the bill at the end of the month, right? So I'm going to do 2.5 plus 5 3/4. My LCD is going to be 4. So that's going to be 2 2/4 plus 5 3/4. So that's going to be 7 5/4. Yeah. But 5/4 is improper. So you're going to divide it. It's actually 1 1/4 as a mixed. And I think that's one that you already know, right? But just in case, 4 goes into 5 one time, 1 times 4. So it's 1 1/4. Remember, all the way back to the beginning of the chapter. So you're going to add the 1 to the 7. And you're going to get 7 plus 1 1/4, which is 8 1/4. And that goes here. Okay. So all of this work here was just to resolve those two fractions. The whole number's already done, yeah? 3 plus 2 is 5, and now this is going back to the beginning. I can just add the whole parts. 5 and 8 is 13 1/4, and that's your perimeter. P, or the whole word perimeter, basically means the same thing. P, perimeter. A would be area. I would use a capital A if I was talking about area, though, because I like to distinguish lower cases from capital letters when I'm using geometric formulas. You might not think it matters. I know when you're taking notes, you sometimes will use capitals and lowercase letters interchangeably. But when you're doing geometry, it's very important to keep track of all your letters. All right, well, that's the idea of perimeter. Want to do another one? I'm sure you do. That was kind of a weird one because it's a trapezoid. Trapezoids, typically all the sides are different. But with a rectangle, they're not. Eight 3/4 and 6 7/8. All right. With a rectangle, I typically only tell you 2 of the sides, but because it's a rectangle, you know that you have another 8 3/4 on this side, and you know that you have another 6 7/8 on that side. Because rectangles are symmetric. If this is the length, then this is also the same length. And we call this the width, or sometimes they call it the height. Really depends on how you're looking at it. Then those have to be the same. So the perimeter is add up all the sides. You can just go around like this, or you can group them together. Remember, I say this a lot, addition is commutative. So you can group them in any way that you feel comfortable with. Notice why I chose this way, because they're already going to have common denominators. Yeah? These guys are already common. So that'll be 16 6/4. I'll have to simplify that in a minute. And these guys are already common. That'll be 12 14/8. Now I need to be careful here. 6/4 and 14/8 are improper. So we need to divide them out. So 16 6/4, that's 16 plus 1 2/4. And again, I'm really starting to step up the mental math here. Look, 4 goes into 6 one time with a remainder of 2. So it's 1 2/4. I'm going to simplify that at the end. If you simplify it too soon, you might end up having to do extra work later on. So it's always better to wait until the very end and then do all your simplifying at the end. How about this one? This will be 12 plus 1, because 8 goes into 14 one time. 1 and what's the remainder? 6? Yeah, 8 goes into 14 one time with a remainder of 6. So that'll be 6/8. Okay. So what do we got now? We got, let's go ahead and group again. We've got 16 and 12. So that's going to be 28. I'm trying to get a good color here. So now we got 1 1/2 and 1 3/4. All right, we're going to need an LCD here. If you prefer to stack them, well, you could try horizontally, but it's probably better to stack. Multiply this one by 2. Yeah, so that becomes 1 4/8 plus 1 6/8. So this becomes 2 10 eighths. 4 eighths plus 6 eighths is 10 eighths. Some of you are probably wishing you had a calculator to do this. Calculators are not going to help you. It's just going to give you a bunch of decimals, and then it will be much harder to then try and translate those decimals back into fractions. I mean, you can certainly try. You know, I'm not going to penalize you for trying, but when I'm grading the test or looking over your work, your responses, whatever I get to see on my end, I can always tell when a student has used a calculator. Immediately, it's like, you know, you can see it. You got dirty hands, you know. I can see the decimals, and I know, why give me a decimal? It happened on the last test, too. And I can see it clearly. We're going to do decimals in Chapter 5. Just hold on a second. Keep the calculator put away for now. We don't need it. All right, 2 and 10 eighths. Again, that's improper. So that's 2 plus 1, because 8 goes into 10 one time, with a remainder of 2. Notice I'm not doing anything with the P. The P is just reminding me that I'm doing the perimeter. You could actually just leave that part off for now, but I'm trying to show good form, which is hanging on to what you're doing. Especially with a long problem, it's easy to get lost. So you're going to have 28 plus 2 plus another 1. That's going to be 31 and 2 eighths, and then reduce now. I could have reduced way back here. I could have. But I always want to wait. Sometimes you get lucky. If this would have come out to be 3 eighths or 5 eighths or 1 eighth or 7 eighths, then I could have skipped reducing altogether. So, you know, keep that in mind. If you're going to reduce, it's better just to do it one time at the very end than it is to do it several times as you're going along. So 2 eighths is the same as 1/4. All right, I hope I don't need to explain why, but I'll do it anyway. 2 is 2 times 1. And 8 is 2 times 4. Cross off the 2's, and there's your 1/4. All right, that's your dose of geometry for the day. The only other geometry formula you might want to know is the triangle formula. I didn't put any triangles in this lesson, but I still want you to know the triangle formula, so we'll come back to that in the next lecture. Okay, so geometry. Now we're going to do a little bit of algebra, some with x's and y's and things, and then we'll do the word problems last. I always save the best for last. It's like dessert. Word problems for dessert. All right. Let's do a little bit of evaluating. We're not going to be solving today. Just going to be evaluating. Evaluate is a fancy way of saying plug in the value. That's what it means. But I'm not going to say plug in the value on the test or the quiz. I'm going to say evaluate. It's one of the main, objectives of this course, other than, bringing you up to speed in math, is really to bring you up to speed in how we speak and how we read and how we interpret a problem. I know that if I were just to say plug in the number, everybody would know what that means. So evaluate, plug in the value. So x is going to become 6 1/5 plus 5. This is essentially a free answer. We talked about this earlier. If you are adding a mixed number and a whole number, you can just add the wholes, 6 plus 5, and then bring down the fractional part. Subtraction's a little tougher, but addition would be pretty much what you would expect. How about evaluate x minus 2 1/3 for x equals 9 3/4. This will be a little tougher. Yeah, a little bit tougher. So I've got 9 3/4. That's my x. Yeah. Minus 2 1/3, which I'm going to rewrite in the stacked formation, sometimes referred to as the vertical. This is horizontal form, and this is vertical form. If you're good at guessing, take a guess right now. What do you think it is? This one's pretty tough to guess, but you might as well give it a shot. If you think you know, scribble it down over here and see if you get what you thought. Oh, and make sure you wrote it down correctly. Look at, somebody almost got extra credit there. Somebody's probably already emailing me right now, but I fixed it. Okay, so it's 9 3/4 minus 2 1/3. What's the LCD? This one's just going to be 12. So this is the case where you do, in fact, just multiply them by each other. That's what we call relatively prime. They're not, 4 is not actually prime, but when you compare it to 3, it's what we call relatively prime. It means that 4 and 3 have nothing in common. So if the numbers have nothing in common, the only way to make them common is to hit them with each other. So you're going to get a 3, and you're going to get a 4. And so now we have 9 and 9/12 minus 2 and 4/12. Oh, I always love it when this happens. No borrowing is required. Borrowing needed. Yeah, because the top numerator is bigger than the bottom numerator. So we're going to get 7 and 5/12. That's your answer. 5/12 is irreducible, so I can leave it. If it was 6/12 or 4/12 or 3/12 or 2/12, then I would have to do more work. But 5/12 you get to stop. Right. There aren't very many 12ths that you get to stop with. You have 5 and 7. Those are the and 11. 11/12. 5/12, 7/12, and 11/12. Those are the ones that are irreducible. All right, let's do some negatives now. I saved the negatives for the end. When we get into algebra, the telltale sign of a good algebra lesson or a good problem, I guess you could call it, would be variables and negative numbers. Those are the two telltale signs that we're really getting into the deep end here. So let's do some negative numbers. Sometimes I give you the numbers ahead of time. I'm going to do two variables, x and y. So this time it's a two-variable expression, and let's make the expression x minus y. So this is your expression. You need to be very careful. I mean, you should be careful all the time when you're doing math, but especially when there are negatives. Yeah. That's a negative, and this is already a negative. So when I plug them in, watch what happens. It's now going to be positive. So negative, negative is positive. Now again, that's only because this y value is already negative. So you're plugging a negative into an expression that already has a negative in it. You want to try the stack method? Let's do the stack method. 7 1/3, 3 4/5. Again, these are relatively prime. In fact, they're actually prime. Yeah. If both of the numbers are prime, then they're obviously relatively prime as well. So we're going to times this one by 5, multiply that one by 3. And remember, we're adding now. It was originally a subtraction problem, but it translated into addition. So you're going to get 7 5/15 plus 3 12/15. So you're going to get 10 17/15. And that's improper. So we need to divide it. 15 goes into 17 one time with a remainder of 2. Again, I just did that one in my head. Right? With mixed numbers and impropers, you really want to, especially when the numbers are small, and these are relatively small numbers, so you want to be able to just, think it out. 10 plus 1 is 11 2/15. And that's your final answer. One more of these, and then we'll end off with the word problems. Sound good? Well, if it doesn't matter. I'm doing it anyway. You can always email me if you have any concerns. I do want to remind people of that. I don't know when you're watching this, but I mean, as long as it's business hours, Monday through Thursday between, 8 in the morning and 3 or 4 in the afternoon, I pretty much get back to you right away. So if you're watching this right now and you have a question, email me right away. You might get an answer within 2 minutes, right? That's the best I could do. I know you can't actually, talk on YouTube to me, but you can send me an email and I'll get back to you as quickly as I can. All right, let's try another one with some negative numbers. So evaluate for x equals negative 5.5 and y equals negative 9 2/5. And this time the expression is x plus y. Now again, you should still be careful, but you can be a little bit less careful because this is an addition problem. So you don't have to worry about, it's going to do double negative type of thing here. All right. We are adding two negative numbers. Okay, so let's remember the rules. When you're adding two negatives, you ignore the sign, you add the values, and then you replace the sign, the negative sign. All right. You know that I loathe the phrase, two negatives make a positive. Oh, God, that drives me crazy. Yeah, because that causes people to make problems here. Two negatives definitely do not make a positive. Yeah, just like two wrongs don't make a right. Yeah, although three lefts make a right. Okay, so we're just going to add the numbers. 5.5 plus 9 2/5, and then we're going to replace the negative sign when we're done. Right? If you're afraid you're going to forget it, put it there now. Yeah, put it there right now, so that negative sign's just on deck. Yeah, it's waiting. It'll be there when you're done. We need an LCD. A lot of these algebra problems, I intentionally make the fractions a little bit easier because I'm just trying to see if you understand the variable part, and I'm not really all that concerned about the numbers. I mean, I want you to get the right answer, but I mean, come on. I'm a person just like you, right? I got better things to do. So I got 5 5/10 plus 9 4/10. So that's 14 9/10. And then bring it over here. And you get negative 14 and 9/10. You never know what you're going to get when you get an evaluation problem, so there could be lots of different versions of this problem. I'm going to stop here and just let you play around with the problems that you see in your homework in your lab and things like that, but it's really random. You might get 2 positives. You'll probably get at least 1 negative. I usually, when I'm doing variables, I usually throw some negatives in there to keep you on point. Well, it's time for dessert, kids. What are we having, Dad? We're having word problems for dessert. These are what I call one-liners. Yeah, one-liners. It's the introduction to the art of solving word problems. Translate and evaluate. 1/5 less than 8. All right, so first let's translate. And then when we're done translating, let's evaluate, which means to find the actual value. Now, I know I've said this before, and I'm probably going to say it a lot of times. The mathematical phrase less than does not mean the same thing as is less than. Right? Less than, there's no is, means subtract, reverse order. All right? It is 8 less 1/5. In fact, it's oftentimes we read it backwards. 8 less 1/5. We often don't even say the than in math. We just say less, which means subtract. 8 less 1/5. That's how they would have said it in the 19th century. It's the old-timey way to say it. Yeah? So you're taking away 1/5 from 8. If you've got good mental math skills, you already know the answer. Yeah? Suppose you deal with money all the time. Suppose you already know how to deal with stuff like that, right? 1/5 is 20 cents. Yeah. So if you have $8 and you take away 20 cents, well, you're left with $7.80. 4/5 is the same as 80 cents. All right. Now, I'm not assuming that everybody's going to be an expert in mental math. So if you can't do it mentally, then you're going to do the stack way. Notice where I put the 1/5. Yeah. It's essentially 0 and 1/5. Yeah. And then 8 is essentially 8 and 0 zeros. You want to line up your fractions with your fractions and your whole numbers with your whole numbers. Now, I already know what I'm going to get. I'm going to get 7 and 4/5. But I want to show you how to mechanically do it so that you don't have to be guessing or hoping that your mind spits out the right number. All right. So we're going to borrow 1 from 8. That'll make that a 7. And we're going to add 5/5. Yeah, look down here. Whatever the other fraction has, that's the denominator you want to use. So 1/5, we're going to put 5/5. So now it's 7 and 5/5 minus 0 and 1/5. 5/5 minus 1/5 is 4/5. 7 minus 0 is 7. And we got exactly what we expected. 7 and 4/5. All right. This is pretty much, for the most part, and it's not in all of mathematics, but for the most part, when we're doing word problems, this is the one operation where you have to reverse the order. So I would just memorize that one. Less than. Yeah. There are others that come down the road in life and in math, but right now, the level that we're at, this is the one that I've been throwing out there. You sense a theme, don't you? I'm going to end this lesson with one that does not reverse. the difference of, that means to subtract and do not reverse the order. I know, we math people and the English language and math get together and they conspire to come up with all these word problems that really make you think about how you are interpreting not only math, but how you're interpreting the language of mathematics. So the word difference is taken literally. So it literally translates into 1/3 minus 5. So do not reverse the order. Keep it in the same order. Okay. Now, 5 is larger than 1/3. So we're going to ignore. We're going to subtract. And then we're going to give the answer the negative sign. Right? Ignore, subtract, and give. Right? Again, that's the same rule that we learned, a month ago or so. Has it been a month? It might have even been longer. All right, so 5 goes on top, 5 and 0 zeros, and then 1/3 goes on bottom, 0 and 1/3. Look here, that's going to be 3/3. Yeah, I'm just crossing out the zeros and replacing them with 3s. And then I have to borrow from the 5 and make that a 4. So this is the borrowing right here, the 3/3. Okay, 3/3 minus 1/3 is 2/3. 4 minus 0 is 4. Bring it over here and make your answer negative. So you get negative 4 and 2/3. Now, I already know what will happen with these types of problems, so I only put a couple of them in there. If you get the wrong sign, it's because you did it in the wrong order, or it's because you forgot the rule of subtracting a larger number from a smaller number. Most mistakes are simple mistakes. Either you forgot or you just neglected or whatever it is. It doesn't mean that all hope is lost, so try not to get too frustrated. I'll be on Zoom at 11 o'clock if you have any questions. But until we meet again, this is Dr. Jordan. I'll see you on the internet.